Hello, welcome back. We got a new topic, but let's start with a joke. So why does no one put clocks on belts? Because that would be a waste of time. Clever, clever, clever. Okay, so let's get straight into it. We're working with time. Seems easy. There's definitely a couple key specific term things that you need to know. Um, First one, we're talking about latitude and longitude. Why it's important, I should probably, yeah. Why is it important? Because it gives us coordinates for locations on the Earth's surface, and later we'll figure out that it influences the time because it does. Now, real quick, latitude and longitude. So the easiest way I like to remember it is latitude is flatitude. So it's talking about the horizontal kind of different layers. And the way that it works, I should probably, okay, I'll talk about this first. So horizontal, we talk about your latitude, flatitude, that makes sense. And then so the other one is if it's not flat, longitude is talking about your vertical. Okay, now later we'll learn that longitude is the one that affects time, but we'll get to that in a moment. Now, the important thing to note here is if we're talking about our latitude, 0 degrees kind of means your equator, and we're talking about north and south. So, for example, this would be I could go 30 degrees north because north is up. I should probably draw a little compass here. I hope you guys know how a compass works. Never eat soggy wheat bix. So, if we talk about the position in terms of latitude, we either go up, which is north, or we go down, which is south. Assuming that I'm just picking random numbers here. You could call it whatever you want. And I guess the larger the number, I guess the larger the south, that means we're going 60 degrees south or we're going 60 degrees north, then technically it goes up to 180 on either side, or 179.9 or whatever you want to call it. Now, that there is important to note because we're going to have to pinpoint some locations later on. Now, we've also got this thing called latitude on the right. So our blue ones here, they kind of go vertically. Now, I've tried to draw it. I know my lines aren't straight. They are straight, but I'm trying to imagine that this is a sphere. So it's spherical. Okay, so it kind of looks like a beach ball. Now, you've got your 0 degrees here. We call that the prime meridian. It goes to this place called Greenwich. I don't know how to pronounce it. It's this place in kind of like Europe, and we kind of call that point zero, right? So that's where we say the middle is, and it kind of works east and west. So, for example, if my zero is right down the middle here, anything towards the right would be east. So let's say, for example, this could be something like 20, could be something like 20 degrees east here. That could be a little bit further, like, I don't know, 50 degrees east. I'm just picking random numbers, but you can see that as the further I go towards the right of that 0 degrees of that Greenwich, my east kind of gets larger and larger. And if I go on the left-hand side, it would make sense that maybe it'll be 20 degrees west, or it'll be 50 degrees west because I'm traveling further towards the west. Okay, knowing how these two work together is imperative for, I guess, kind of the next part here. Okay, so for the next part, it's understanding the position. Now, it's a position on Earth. Every country, every place has a coordinate. Your house has a coordinate. Your country has a coordinate. Everything's got a coordinate. And the way that it works is you have latitude and then longitude. Okay, so there's a particular latitude and a longitude that kind of pinpoints your location. So again, latitude meaning north or south of the equator, and then longitude meaning east or west of Greenwich. So for example, this is a random place, but maybe somewhere is 40 degrees south, but 10 degrees west. And we'll do a example real quick. Okay, so example, given the equator and the prime meridian, so the equator is your red line in this case, and your prime meridian is your blue line. I should probably write 0 degrees here and 0 degrees here. So we know that. Given these two, we want to plot the following points. The first one is nice and easy. I can see that AA, oh, sorry, 0, is just where those two kind of lines meet. That's it. Now, if I'm talking about B, I go 40 degrees south. And so I'm just going to say, for example, 40 degrees south, because I've gone down 40 degrees. And if I go 10 degrees east, remember, never eat soggy Weet-Bix. That means I travel 10 degrees to the east here. And I'm trying my best here to make it look like I've drawn something here. All right, and that point where they intersect, I guess that would be our B, right? 40 degrees south. I should also be very, very careful to highlight or to label these quite well. And this is 10 degrees east. Okay, now keep going. We've got C and D as well. If I'm talking about 10 degrees east and 10 degrees north, that means 10 degrees north would be slightly above. 10 degrees north, and that intersection point still on the 10 degrees east, that would be C. And then I picked the random one here if I went 60 degrees south, so that would be even lower than the 40. That would be 60 degrees south, and then 50 degrees west would be this way here. So west is kind of to the left of your prime meridian, and wherever that kind of meets up, that there ends up becoming your point D. Okay, hopefully that makes sense. A lot of the questions will be based on kind of naming certain coordinates. It's going to be helpful for us when we kind of get onto the next topic. I hope you've drawn your diagram large enough that it doesn't get too crowded. Draw it as neat as you can. I guarantee it'll help out in later questions. All right, hope that helps. I believe that is it, and I'll catch you in the next one. All right, bye. See you later.